Alright, we are asked to solve this equation, and we have multiple methods that we've learned in class. So one way we learned in a previous chapter is that we can solve this by factoring. So to do that, we need to think of two numbers that multiply to 31, and they have to add or subtract to negative 10. So the only numbers that multiply to 31 are 1 and 31. So there is no way to add them or subtract them to get this negative 10. So therefore we cannot solve this by factoring. We need to choose a different method. So the next way I'm going to discuss is to try to solve it using the quadratic formula. Okay, so the quadratic formula, we're going to go ahead and substitute. We have a is going to be the number in front of x squared, which if there is no number, the coefficient is 1. And our b value is negative 10. And our c value is 31. So go ahead and plug those numbers into the formula. Okay, so this was going to make a positive 10, so we're going to have a positive 10. Negative 10 squared is 100. And then negative 4 times 1 times 31, that's negative 124. And then 100 minus 124. Okay, so then once we get to this situation where we have three numbers, everything's completely simplified up to this point. So now that we have the three numbers, we take the radical and ask ourselves, can we simplify it? So we have the square root of negative 24, which is not a real number. So it's not a real number, but we know how to work in the complex number system. So we're going to go ahead and simplify the square root of negative 24 as a complex number. So remember that the square root of 24 can be simplified like we learned last chapter to 2 radical 6, but because it was negative, we're going to have 2i radical 6. Okay, so then after we simplify the radical, then we ask ourselves, is there a number that can divide 10, 2, and 2, which is 2. So we're going to divide each of the numbers by 2. Not the 6, though, because it's in the radical. So our final answer is going to be 5 plus or minus I radical 6. If you were going to put a 1 there, that's not wrong, but it's not as simplified. Let's get rid of it, because there's an I. 1I is the same thing as I. All over 1. Well, when we divide something by 1, that doesn't do anything, so we can get rid of that 1 too. So this would be our final answer. Okay, so if we couldn't factor this, we tried quadratic formula, we got an imaginary answer, and now I'm going to show it again, so you can stop the video. However, I'm going to continue and I'm going to solve it by completing the square. So you can use completing the square whenever you have an x squared and an x term in the equation here. So to use the completing the square, we have to get the constant all on one side and the x values or x terms on one side. Then to complete the square, on the side over here, you're going to take b, which is negative 10, and divide it by 2. Then you're going to take that negative 5 and you're going to square it, which is 25. Well, that is our number that we need to add to both sides. Remember, we could do whatever we want to an equation as long as what we do to one side, we do to the other side. So now we have negative 6. Now we have this new trinomial here that if we got this number correct, I should be able to factor this trinomial on the right side such that these both are going to be the same. So what multiplies to 25 and adds or subtracts to negative 10? It's always going to be this number right over here, negative 5. So negative 5 times negative 5 is 25, and negative 5 plus negative 5 is this negative 10 right here. So we did all of this work over here so that now we could take this and write it like this. Now that is completing the square. We have just completed the square, so that now I can continue and solve this equation using the square root property. Okay, so now that we have completed the square, now the whole purpose of it is so I could do this and get rid of this, now that I have it written like that. Remember, we need plus or minus whenever we insert a radical into a square root into the equation. So now we have this, which the square root of negative 6, that can be simplified to this. And then we would add 5. So I'm going to put the real number first, and then the radical, because it has an I, second. And that is our solution using completing the square, which is exactly what we got here, but this method was using the quadratic formula.